Hi, I'm Tom, coming to you from Cleveland, Ohio. I am at the world headquarters of the International Consortium for Sourdough Science and Research, also known as my kitchen. Thank you for selecting my video. In today's video, this is a continuation of a series that I've created called When is Bulk Fermentation Done? This is intended to help beginning sourdough bakers answer the question that everybody struggles with: when do you cut off bulk fermentation? In the series of videos up to this point, I've introduced an innovative new tool called the Bulk-O-Matic system. This is something we've developed here at the Institute that uses 9 variables to determine when bulk fermentation is done. We will continue to use this tool in today's video to teach you the tools and techniques for determining the answer to this complicated question. Now, in episode 3, the prior episode in this series, we used the Bulk-O-Matic system to evaluate 4 loaves of bread and determine when the dough was ending bulk fermentation. I cut off each one of those batches at 45-minute intervals, and then we were able to bake up the loaves and look at the crumb and determine whether the loaves were underproofed, overproofed, or somewhere in the middle. In that example, I cut off bulk fermentation at 45-minute intervals, and the percent rise in the dough was roughly 0% on the first batch, 10% rise on the second batch, 20% rise on the third batch, and 30% rise on the fourth batch. And we saw very interesting results in that video. Coming out of that video, many of my YouTube subscribers commented that they'd love to see what happens after 30%. So what we're going to do today is bake 4 more loaves and do the bulk fermentation, looking at a percent rise of 40% rise, 50% rise, 75% rise, and 100% rise, or a doubling of the dough. So now we're really going to be pushing into the territory of what does bulk fermentation look like and what does bulk fermented dough look like as you start to approach overproofing. So when I started baking sourdough bread, I was always afraid of overproofing my loaves, so I was a chronic underproofer. And it was really until the first summer that I spent baking sourdough, when the warmer ambient temperatures just push everything along and you start to overproof a couple of loaves. It's really just part of the learning experience. You have to learn where that cutoff point is between fully proofed and overproofed. So that's really what I'm going to try to bring out in this video today, is to start to diagnose the dough when you're looking at it and find that perfect spot right at the edge of overproofing, because sometimes that's where some of the best loaves occur, is right when you're pushing them up to the point where it's almost about to tip the scale towards overproofing. We'll try to find that point today. Now, today's experiment is a continuation of what I did in episode 3. So I'm not going to go back and repeat all of the upfront content. I'll just give you a quick update. In all of my experimental videos, as many of you know, I use the exact same recipe: Chad Robertson's Basic Country Loaf from the Tartine Bread Cookbook. It's a very popular, well-known recipe, and it works well in these experiments. I won't go through the details of that recipe. You can read more about that or watch that part of the video in episode 3. The other thing that I do in episode 3 is I go through in detail the 9 criteria that we use to determine when bulk fermentation is done. Rather than go through these again and repeat all that content, you can watch the first 15 minutes or so of episode 3 and understand the recipe, the setup for the experiment, and the 9 factors on the Bulk-O-Matic system. So what I'm going to do in today's video, in the interest of time, is we will just pick this up after I've mixed the dough and done 4 stretch and folds. That takes us to 2.5 hours into the process, and then we'll start there with these 4 batches of dough, and then we'll look for, as I mentioned, 40% rise, 50% rise, 75% rise, and a doubling of the dough. That'll be the experiment for today. So now let's talk a little bit about using percentage rise of the dough as my cutoff points for these 4 experimental loaves. In episode 1 and episode 3, I used a time cutoff, 30-minute intervals in episode 1, 45-minute intervals in episode 3. Today we're just going to focus on percent rise and just let the time run as it may. So let's talk a little bit about percent rise before we go forward. When you measure the percentage rise in the dough, in this particular recipe, the tartine recipe, it calls for a relatively low percentage rise in the dough, 20 to 30% rise is what's recommended, and that typically bakes up very well. I tend to push right up against that 30% rise. I've occasionally gone up to maybe 35% or a little bit higher than that. But this recipe will fully proof with a 30% rise in the dough. Other recipes call for a higher percent rise. You'll see some that call up to 50% increase. And then what we're going to test today at the extreme end is a doubling of the dough, or a 100% increase in the volume of the dough. Now, I see this in some recipes, and I hear a lot of people use this as a recommendation when you ask people on social media groups, how do you determine when bulk fermentation is done? A lot of people say, just wait until the dough doubles in size. I think if this dough doubles in size, it's going to be wildly overproofed. I really am skeptical of recipes that call for a doubling in size. The reason for that is because I'm incredibly meticulous about measuring the percent rise. What we're going to use today to measure the percent rise in the dough are these bowls where I measure these very precisely with milliliter markers on here, so I can tell the difference between a 10% rise and a 15% rise, for example. When some people say, just let the dough double, they're just looking at a bowl of dough and saying, yeah, that kind of looks like it doubled, without actually measuring it. I don't do that around here at the Consortium for Sourdough Science and Research. We obviously measure things precisely. So we're going to measure this. I'm actually going to do a measured doubling of the dough so that we can prove or disprove this kind of general rule of thumb that a lot of people use, is to just let the dough double in size. I don't think it's going to work, but maybe I'll be proven wrong. Now let's talk about how we measure the percentage rise in the dough. When a recipe calls for a percentage rise in the dough, it's based on the percentage change in volume, not the percentage change in height. Because unless you're using a perfectly straight walled vessel, the change in height will not be equal to the change in volume. This is what a lot of people use, is a big bowl like this. You put your dough in here, the recipe says, look for a 30% change in 30% rise in the dough. You can't tell what 30% is in a bowl like this. Number one, it's not transparent, so I can't see through the side. I can't tell where my starting point is. Number two, it flares out at the top. So as the dough is rising in height, it's rising much more in volume because it's spreading out as it goes. This is a horrible bowl for trying to measure the percent rise in your dough. If you do have something like this, which is transparent but it's not straight-sided, you want it to have the milliliter markers on the side. So this measures the volume as it rises in the bowl, so it accounts for the irregular shape of the vessel. So you want to have your milliliter markers on there. I use these bowls where I put my own milliliter markers on here, so I have a very precise measurement. And here at the Institute of Research and Science, if I really want to be precise, I've actually used these chemistry beakers, perfectly straight-walled vessel with very fine grained markers of milliliters on the sides here, so I can really do fine measurements there. So when we talk about the percent rise in the dough, it's the percent change in volume, not the percent change in height. Use a vessel where you can actually measure it. You need to have milliliter markers on it, or you need to have a perfectly straight-walled vessel if you're using a rubber band or something like that. So now we're ready to mix the dough. I'm not going to go through all the details here because it's the exact same process I followed in episode 3 if you want to go back and watch that same recipe, same flour, exact same process. Here's a summary of the recipe that I'm using in this experiment if you want to pause the video here and review it in more detail. So I'm going to mix the dough per the recipe. I will do 4 stretch and folds, and then I'll meet you back here in 2 hours and 30 minutes of my time. Now here at the Consortium for Sourdough Science and Research, in addition to sourdough bread baking, I also do a little tinkering with time travel and teleportation. So I've rigged up this system where I use this meat thermometer along with my kitchen scale. And if I put my hand on the scale and type in here that I want to come back in 2 hours and 30 minutes, and we're back. That always feels so weird. Wow. So I took notes along the way. It's hard to remember what happens in a fraction of a second. So here's what I did. I mixed the dough. I let it sit for 30 minutes. That included the water, the flour, and the starter. We do not add the salt, but we do add the starter. It sits for 30 minutes. Then I add the salt. It sits for 30 more minutes. Then we start doing stretch and folds. I did 4 stretch and folds on the large mass of dough, and then I divided these into 4 equal containers. So we're 2.5 hours into this process, into bulk fermentation. I'm done with stretching and folding this dough. This recipe calls for a minimum of 4 stretch and folds, sometimes 5, but this dough felt really good after 4. So we're gonna cut it off here and just focus on the percent rise. We're 2.5 hours in. The minimum time that this recipe would recommend for bulk fermentation to be done is 3.5 hours. The range is 3.5 to 4.5 hours. We're gonna be pushing the outside of the range here. So I'm just gonna let this dough sit now and put it in my proofing chamber. This dough has been in my proofing chamber at about 80 degrees Fahrenheit, which is 26 degrees Celsius, the entire time, really constant temperature, which is right in the range of what this recipe recommends, which is 78 to 82 degrees Fahrenheit, or 25.5 to 28 degrees Celsius. We're right in the middle of that. So we're early from a time perspective. We're great from a temperature perspective. I'm just gonna let this sit now until it gets up to about a 30% rise in the dough. That's where we left off in episode 3. That was our loaf number 4 in episode 3, which was a 30% rise. That was the furthest along loaf that we did. Then I'm gonna compare this dough to what that loaf number 4 looked like in episode 3, just to see if this is a true continuum of where we left off. I think it will be, because I'm using the exact same formula, the same flour, the same temperature, everything here. But we'll just do that checkpoint, and then we'll start watching this, and we're gonna do loaf number 1 at 40% rise, loaf number 2, 50% rise, loaf number 3, 75% rise, loaf number 4, a doubling or 100% rise in the dough. And then we'll assess the criteria on the Bulk-O-Matic system against the 9 criteria, so you can start to get a feel for and see and smell what the dough looks like as it's moving along that continuum, possibly pushing towards overproofing as a learning experiment. Okay, it's been about 5 hours and 45 minutes since I initially mixed the dough, and I've been waiting for this to get up to the 30% rise mark, which is where we ended the last video. We are right about at that point. Let's go through the 9 criteria and see where we are. This will give us our benchmark to compare back to episode 3. So this is 5 hours and 45 minutes is our timing. That's on the high end. That's outside the range of the recommended timing, where the range is typically 3.5 to 4.5. It's not uncommon with this recipe. I typically go 5.5 hours. The temperature of this loaf is sitting right at 81 degrees Fahrenheit. That's right where we want to be. That's 27 degrees Celsius. So we're on a little bit of the high end of the range between 78 and 82, but we started out lower. So let's call this kind of the average temperature has roughly been about 80 degrees, which is in the middle of our range. The percent rise is sitting right at 30% on the money, maybe a little bit higher. Then we look at the other observational variables. Is the dough domed on top? It clearly is. I can see it really showing a shoulder around the edges. Are there bubbles on the top? Yes, there's one giant bubble here, which usually starts to form as you get up at about this 30% range with this recipe. You get a few of these big bubbles on the top. Are there bubbles on the side? I'd say yes. I wouldn't call that vigorous bubbling on the side, but it's up there. It's better than average bubbles on the side of this loaf. The wobble test, you can start to see this loaf is loose. So that top of the loaf starts to wobble or wash up against the sides of the bowl, which indicates there's a lot of aeration here. Let's do a window pane test to see where our gluten structure looks like. This feels thin to me. But yeah, this is actually losing a little bit of strength. So we're pushing towards overproofing with this gluten the way that it's sitting right now. And then the smell test, if this smells like raw flour, it's underproofed. If it smells like starter, it's overproofed. So what I'm looking for here is kind of a sweet, ripe smell, like a ripe cantaloupe. I don't want this to go too far towards an acidic smell. This smells sweet and ripe, just like what I would expect for this to be at this point in the bulk fermentation process. This is typically where I would cut off this loaf, and this would make a perfectly nicely proofed loaf with these criteria. So I'll just put the indicators on the chart. You can pause there if you want to look at these in more detail. This is just a checkpoint to tie back to episode 3. This is the equivalent of loaf number 4. We're going to keep going from here now and let this go until it gets to 40%. Then I'll start taking these out, putting them in the shaping baskets, and we'll bake them up tomorrow and inspect the crumb to see what that longer bulk fermentation time does to the crumb. So loaf number 1 is done. This has risen 40% from the time we started, which was about 6 hours ago. That's pretty typical with this recipe for me. So let's go through our criteria. Let's take the temperature. Now this has been in my proofing chamber, which I warmed up a little bit. It's sitting now at 82 degrees, 83 degrees Fahrenheit. So now we're pushing the high end of that temperature range, but we started out on the low end of the range. So on the average, this pretty much was right in the middle of the range, about 80 degrees Fahrenheit, 27 degrees Celsius during the fermentation time, but it's pushing a little bit warm end of the range right now. As I mentioned, the time is 6 hours. That's outside of the range, but not atypical for this recipe. And the percent rise is 40% rise in the dough, which is outside of the recommended range where the high end is 30. Is this domed on top? It clearly is. Are there bubbles on the top? Just seeing a few large bubbles forming kind of under the surface, but I'm not seeing the real bulbous ones pushing up through here. Are there bubbles on the side? Clearly, you can see here a lot of bubble activity there fermenting. When we do the wobble test, this loaf is pretty loose. So when I shake that, I look at how that's moving up against the sides of the bowl. That's a pretty well aerated loaf. The window pane test, I'm a little concerned about based on that last one. Now this window pane looks pretty good. You can see it tearing there. So I'm starting to get a little bit of gluten deterioration, but not bad. But every point from this point forward, the gluten will start to deteriorate more and more. And that's really what causes the overproofing. And then lastly, the smell test. Now this definitely has the sweet smell, and I'm starting to smell a hint of that vinegar smell, which also comes with overproofing. Just a small touch of an acidic smell in here. So this is a 40% rise. I've baked loaves like this before. This should still come out okay, but we're starting to push towards overproofing in my opinion. So here's the summary. Let's just go down through the chart. Temperature 82, time 6 hours, percent rise 40. Is it domed on top? Yes. Are there bubbles on top? There are a few. Bubbles on the side, I'd say quite a few. Wobble test, loose and aerated the way we want it to look. The window pane is not strong and translucent. It's starting to go past that midpoint now, heading towards weak. And then the smell, similarly, is heading to the right of sweet, and it's moving more towards acidic. That's the summary for loaf 1. Now, what I do with all these loaves, similar to the others, is I don't do any pre-shaping or final shaping on these loaves, because what I want to do in this assessment of bulk fermentation impact on crumb is really just take this dough as is, put it into a shaping basket, put it in the refrigerator for the overnight cold retard, and then bake it up tomorrow. The reason I do this is because shaping can introduce all kinds of irregularity into the crumb. And then when you try to do the assessment a day later after you bake it, you can't tell really if the crumb is due to the impact of bulk fermentation or the shaping. So I just eliminate the shaping step, and we actually get some pretty decent loaves out of this. I've done this in my other ones. It's just like putting an X-ray machine on the dough at the end of bulk fermentation. So what I do now is I'm just going to carefully lift this dough out of this bowl and flop it into my shaping basket. I also look at, when I pull the dough away from the bowl, I can see gluten strands coming away. The more gluten strands you see indicates that you're further along with the proofing. This dough is incredibly loose. You can see how wobbly that is. Super loose dough, fully aerated, nicely proofed, heading towards overproofing for sure. So now I just try to scoop this out. You can see how loose that loaf is. That is really a droopy loaf. And then I flop it into that pan. That was not a very good flop because that introduced some irregularity to my loaf, but this will settle down in the pan and reform itself. Try to improve that on the next one. And then the last thing I like to do once I get it in the pan is I do the shake test. You can see how loose that dough is. And when I say the dough is loose, what I mean is if this dough is stiff, you would see that whole loaf rocking back and forth in the pan. When the loaf becomes loose, it immediately spreads out against the sides in the shaping basket here. And when I shake it, the top of the loaf is wobbling. The whole loaf isn't shaking, just that top. Look how loose that is. That's a really nicely proofed loaf. Sometimes these bake up perfectly when they look like this. We're pushing the limits here. Now normally this recipe would call for a 30-minute bench rest after the pre-shaping. I'm not doing pre-shaping, but I'm going to give this the 30-minute bench rest to be consistent with the recipe. So this will sit on the counter for 30 minutes, then we'll put it in the refrigerator for the overnight cold retard and bake it up tomorrow. This is loaf number 2. It has been bulk fermenting 6.5 hours since we mixed the dough initially, and we are just at 50% rise on this one, which was our target. Let's go through the criteria. Take the temperature. This dough temperature is sitting at 81 degrees Fahrenheit, 27 degrees Celsius, right where we want to be. As I mentioned, 6.5 hours and 50% rise. Is the dough domed on top clearly? Are there bubbles on the top? Yes. Here you can really see what I normally see at the end of bulk fermentation. Just kind of large, thin, almost transparent bubbles that you see around the edges there. Are there bubbles on the side? Yes. And this is interesting because what you see here now is these bubbles are becoming a little bit smaller and more condensed. So during the bulk fermentation process, those bubbles on the side will often be large, irregular shapes, and then over time they'll get smaller and rounder, and that's an indication of what will happen to your crumb as well. You get a little preview of it there right on the side. That's what an overproofed crumb will start to look like. It's kind of small, pinhole-sized, round circles. Let's do our window pane test and see if we can determine how our gluten is standing up. Grabbing a little bit more dough here this time. That actually looks pretty good. I grabbed a little bit thicker slab of dough, then there you see it tore at the very end. But I got a pretty good stretch on that. But we're definitely losing gluten structure as more time passes here. That's what causes the overproofing. And then the smell, very sweet smell. Just that hint of acidity that I smelled in loaf number 1 as well. But this dough actually feels and looks pretty good. It's pretty loose. If we do the wobble test, you can see here, super loose dough splashing against the sides. So this dough is pretty far along, but I wouldn't call this overproofed just by looking at it, but it's moving in that direction. So for the record, let's just go down through the chart. 81 degrees Fahrenheit, 6.5 hours, 50% rise, nice dome on top, large bubbles on the top, many bubbles on the side, but starting to get smaller in size. The wobble test, loose and aerated. Window pane test is a little bit past strong and translucent and starting to weaken. And the smell test is just to the right of fruity with a hint of acidity. As I start to take the dough out of the bowl, see those gluten strands right on the side there. When you start to see that gluten when you're touching the dough, that's an indication it's going too far, in my experience. It's not horrible, but when you see those gluten, that web of gluten coming off the side of the bowl, that's an indication you gotta move. You gotta move pretty quickly with this loaf. And when I scoop it out, I feel, look how loose that dough is, really super loose. And I'll lay this one in. That's a little bit better. A little better on the flop. You can tell by looking at this dough, this would be incredibly difficult to shape if we were trying to shape this. Sometimes with really loose dough like this, the shaping will give it more structure, and sometimes you can pull it off, but this is going pretty far. And there's that shake test. Look how loose that dough is. That's really just a good visual indicator of when your dough is right on the edge. But like I said, sometimes these loaves that are right on the edge, you know, bake up really nicely. Sometimes that's where the magic happens. So this loaf will get its 30-minute countertop rest at room temperature, and then it will go into the refrigerator for the overnight cold retard. We'll bake it up tomorrow. Okay, this is loaf 3. This was intended to be our 75% rise loaf, and this has been at about 60% for the last hour or so. We're sitting at 7.5 hours since I mixed this dough, and this is an example of what I call the stall point. The stall point is where, just like you would think, this dough rises, 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 then it just gets to a point where it sits there and it won't go any higher. So what happens here is the yeast is starting to run out of gas. The yeast only has a certain amount of energy in it, but what's also happening is that in addition to the yeast in your sourdough starter, you also have lactic acid bacteria. The lactic acid bacteria is competing for the same food as the yeast, and the lactic acid bacteria outnumbers the yeast cells by something like 100 to 1. So the lactic acid bacteria is starting to out-eat the yeast, and it's just slowing down the rise. And then the lactic acid bacteria also creates something called the protease enzyme, and this happens when it sits for a long period of time or gets up to high temperatures. The protease enzyme starts to eat the gluten. So the yeast is trying to fill the gluten matrix, and the protease enzyme is eating the gluten matrix. So the yeast is trying to fill up the balloons, and the protease enzyme is popping and eating the balloons. So you get these countervailing forces here where the yeast wants to increase it, but the protease enzyme starts to decrease the size of the gluten matrix, and you'll just sit here at the stall point for a while. So right on the edge of what I'd call the end of the rise, or at least I believe so. This might go a little bit longer, but we still have another loaf in the proofing chamber. So I'm going to cut this one off at 60% rise instead of 75, just to salvage this loaf, see how it looks. It gives us another data point, and then I'll let the last one go for as long as I can to really see if we can hit that doubling that we were targeting. So let's do the tests on this loaf. Number 1, temperature. All these loaves have been sitting in the low 80s. This is sitting at 81 degrees Fahrenheit, right where we want it to be, 27 degrees Celsius. That's a great fermentation temperature for this recipe. Time, 7.5 hours. That's really getting up there. I mean, this recipe calls for 3.5 to 4.5 hours. We're more than double, you know, the low end estimate of 3.5 would have been 7 hours if we doubled that. So this is starting to get outside of the conceivable window for how this would work. The percent rise, as I said, 60%, and it's just stalled out right there. Are there bubbles on the top? You can see the top of this looks smoother. I do see one bubble up there through the top, but you can just tell that this dough is losing some life to it. It just looks a little flatter on top, even though it's domed. Do we have bubbles on the side? We do, but similar to that last loaf, the bubbles are shrinking. So we're getting these small bubbles, these pinhole-sized bubbles on the side. That's a preview into what your crumb is going to look like. This is all the signs that this is heading towards overproofing. The wobble test. This does not look significantly looser than the prior loaf, but this is what I would call a loose aerated loaf. And then the window pane test will give us a view into what's happening with our gluten. This dough feels thin. I mean, as soon as I grab it, I can tell that it's just losing structure. Very carefully stretching that. Still getting a decent window pane there, but you can see how that dough is just, now this dough is tearing apart. I mean, I'm really trying to stretch that. So this is breaking down from a window pane perspective because the protease enzyme is eating the gluten. That's exactly what's happening here. And then the smell test. This still smells pretty sweet. I smell that hint of acidity. Really, all three of these loaves have smelled about the same. This hasn't turned the corner to where it smells like my starter yet. You know, so I'm looking at these other indicators. This still smells okay. Just that hint of acidity. So let's put the chart up on the screen Temperature 81 degrees Fahrenheit, 27 degrees Celsius, time 7.5 hours, really pushing the extreme there. Percent rise is really parked at 60%. Is it domed on top? Yes, but it looks, flatter. Bubbles on top, a few. Bubbles on the side, many, but they're decreasing in size, and it's starting to look like a deflated loaf. It's heading that direction. The wobble test, still loose and aerated, doesn't look too bad. And the window pane test is weakening. The smell test is ripe and sweet, but pushing towards acidic like the other loaves. So this loaf doesn't look materially different to me than the prior one, the one that rose 50%. This one has bulk fermented about an hour longer. So this will give us a good indication of what an extra hour of proofing does. Let me try to get this out of the bowl. Super soft loaf. I mean, this is, feels like a ball of air, which is great if the gluten can hold up. You're really you're in a race against time here to see if you can basically get this to not deteriorate any longer, anymore. Super soft loaf. Good flop into the pan. And then I'll shake this one. Look how loose that is. That is a super, super loose loaf. It's a good example of what a really proofy loaf looks like. That's what I'd call this. Some people use that term, proofy. It's like Simon Cowell used to use that word pitchy on American Idol. This loaf is proofy. Let's put this into the fridge after its 30-minute bench rest, bake it up tomorrow, and see how it looks. Loaf number 4 is done. This was our doubling loaf, 100% increase in volume. This took 9 hours to get here. Now, as I said at the beginning of this video, some people use a rule of thumb. Some recipes say mix up your dough and wait till it doubles in size, but I don't believe they actually measure the doubling. I think they just kind of look at the dough. This dough is a measured doubling. This started at 375 milliliters of volume. It's currently at 750 milliliters. This took 9 hours. If I had just been eyeballing this, I would have said 4 hours ago that this looked like it doubled, but it actually didn't double. So when you see recipes that say the dough should double, I'm always suspect whether they actually mean a measured doubling or an eyeballed doubling, or if there is such a thing as an eyeballed doubling. So we're going to see what happens here when you actually let your dough double. 9 hours is double the time on the high end of the range that this recipe recommends for bulk fermentation. It recommends 3.5 to 4.5 hours. 4.5 times 2 is 9. So this is wildly beyond the recommended range. Let's look at the temperature. This is in the recommended range of temperature, 81 degrees, right where all these loaves have been sitting. That's a good fermentation temperature. Let's look at the other criteria. Is this domed on top? Clearly has a really nice dome on top. Are there bubbles on top? There's one small bubble left on top here. Most of the bubbles have disappeared, and the top is really smoothed out in kind of a peculiar way. You can tell the texture of this dough is changing. Are there bubbles on the side? There are, but they're declining in number, and you can see there are these very small kind of pinpoint type bubbles that we saw as these loaves started to get past the 50% point. You get these tiny dots of bubbles in there. The wobble test, nice, loose, aerated dough. This doesn't look horribly overproofed when I'm shaking it, but look at that dough splashing up against the sides. That's a really loose, a lot of air in that dough. Let's try the window pane test to see how our gluten structure is hanging in there. Now this dough is super thin and tearing. So you can see right from the start, I can barely get a window pane on this before it tears. There's still some gluten in this loaf. I mean, this is not a bowl of starter yet, but this is heading that way. It's just really tough to keep the structure. So when you see that, that means that the gluten structure is breaking down. the protease enzyme has arrived and it's eating its lunch, which is the gluten. So the yeast is trying to fill the balloons and the balloons are popping. This is heading in the direction of overproofing. The smell, definitely more acidic. So this one has really turned the corner from that sweet smell that I smelled in the last 3 loaves, definitely to a little bit more of a vinegary smell as the prominent smell. So let's just go through the chart for the summary here so you can see what a double loaf looks like. Temperature stayed in the range, 81%. Time, 9 hours. That's really off the chart from what I typically use. Percent rise, 100%. That's at the max. Is it domed on top? Yes, it stayed domed on top. It did not deflate. Are there bubbles on top? Not many. So this is really past the many bubbles, heading towards the deflated bubbles. Bubbles on the sides, many, but very small. The wobble test, I'd say it's loose and aerated, not liquefied, but more loose and aerated than the prior ones. Window pane is starting to get weak. Clearly this loaf is the worst of the 4 that we did. And the smell is past the sweet smell as the dominant smell, moving into that acidic smell. So this is a good test for when you really push some of these variables. Let's see how it bakes up tomorrow. First, I need to get it out of this bowl. Let me see how it feels. Super airy. It almost feels fragile. I don't know a better way to describe this, but as I'm touching this, it's not bouncing back. It's like, I feel like every time I touch this, I'm doing damage to it. I see those gluten strands, that webbing coming away from the side of the bowl, but not as strong of webbing as I saw in those prior ones. Everything's breaking down here in my hands. I can feel it. And the aeration is deflating as I'm trying to get this out of the bowl. Let's see if I can lift it out here. Super sloppy loaf. Not a bad flop into the pan. This loaf is not completely gone. I mean, I've overproofed loaves where it looks like a bowl of starter, and you don't have any shape here. This is still a salvageable loaf, but it's pushing the limits. So now, let me show you the shake test here. That's just a shaky gob of dough in that pan. Slightly worse looking than the last loaf, the 60% rise loaf. This is more liquefied, less cohesive dough. So loaf number 4 will get its final rest on the countertop for 30 minutes, then go into the fridge for the overnight cold retard. We'll bake it up with the other 3 in the morning. See you tomorrow. It's the morning of day 2. It is time to score and bake the loaves. So let's recap what we did yesterday. After I bulk fermented the loaves, I flopped them into those shaping baskets, let them sit on the countertop for 30 minutes per the recipe. Then they went into the refrigerator for an overnight cold retard. Now this is important to understand what happens when the loaves go into the refrigerator, because we think when we cut off bulk fermentation, somehow the yeast just stops fermenting. It doesn't. The yeast doesn't know that bulk fermentation is over. The yeast only knows the temperature. So the loaves keep fermenting. It keeps fermenting during the 30 minutes on the countertop, and it keeps fermenting in the refrigerator. This is a chart that I've used in some of my other videos. I'll put this up on the screen for you. But this shows what happens to the temperature of a loaf when you put it into the refrigerator. I put a 78 degree Fahrenheit, 26 degrees Celsius dough temperature loaf into the refrigerator and then put a continuous probe thermometer in there. And you can see what happens in the half-hour intervals along the bottom of the chart. The temperature declines, but it declines incredibly slowly. So when you put your dough into the refrigerator, people think it immediately stops the fermentation process. It doesn't. It just slows it down. That's why it's called a cold retard. Retard means slow down. So what you're seeing here is these loaves keep fermenting. It takes, almost 4 hours for the dough temperature to get down to 50 degrees Fahrenheit or 10 degrees Celsius. That's still an active fermentation temperature. In fact, the dough will keep fermenting until it gets down to about 37 degrees Fahrenheit or 3 degrees Celsius. My refrigerator is set to 37 degrees Fahrenheit, and it takes about 10 hours for these loaves to get down to that refrigerator temperature. So after 10 hours in the refrigerator, the yeast is really asleep. I mean, it's in hibernation basically. The lactic acid bacteria continues to work at low temperatures, and that's what continues to develop the flavor at a low retard, at a cold retard. But the lactic acid bacteria even prefers temperatures around 40 degrees Fahrenheit or 4 degrees Celsius. Once you get down to 37, the loaf is kind of in suspended animation for our purposes here. So these loaves were in the refrigerator for about 14 to 15 hours. I put them in at successively longer bulk fermentation times, so I'm taking them out at those same intervals to try to keep that fermentation total cold retard time around 14 to 15 hours. And then you might ask the question, well, isn't there a big difference between 14 and 15 hours? I mean, we were measuring bulk fermentation in minutes, and now we're looking at the cold retard in hours. Once you get down to that refrigerator temperature after, say, 10 hours, whether you go 12 hours versus 13, or 13 versus 14, or 14 versus 15, there's no material difference at that temperature. So these loaves are coming out roughly between 14 and 15 hours of cold retard in the refrigerator. The way that I bake these loaves is I preheat the oven to 500 degrees Fahrenheit, that's 260 degrees Celsius, with the Dutch oven in the oven. I reduce the temperature to 450 degrees Fahrenheit, 232 Celsius when I put the loaves in with the lid on. I bake for 20 minutes with the lid on, take the lid off, and then bake for another 15 minutes or so. So these loaves, 250 gram flour weight loaves for me with this recipe, bake up in about 35 minutes. So I've scored and baked loaves 1 and 2, and I can tell from what I saw in loaf number 2 that these loaves are starting to show signs of overproofing. So I'm going to show you on loaf 3 here what this dough looks like to help you diagnose your proofing problems even during this scoring process. So as I said, these loaves were in the refrigerator for about 15 hours overnight, just in my shaping baskets, no pre-shaping and no final shaping of these loaves. I dust the bottoms with some white rice flour to keep that from sticking. And then I flip these loaves out on parchment paper. So here's what this loaf looks like coming out of the refrigerator. This is standing up pretty high. I always look at how high it's standing up. So this has a lot of air, pretty good shape. And then I just tuck these ragged ends under here. And as I'm doing that, I can feel how loose this loaf is. It's very incredibly airy and loose. So a very stiff loaf would be underproofed. I could feel it already if it were. A very overproofed loaf is very airy and loose. Now let's talk for a minute about the poke test. I don't typically use the poke test because it's not reliable for loaves coming out of the refrigerator. The poke test is usually used when you're proofing loaves at room temperature, but I'll do it here anyways just to demonstrate it. With the poke test, what you're doing is trying to see how much the dough springs back when you touch it with your finger. And as I said, in the refrigerator, this loaf is more stiff, so this is not reliable. But you dip your finger in some flour, push it into the loaf, and then if this bounced all the way back immediately, that generally means that the loaf is underproofed. That means there's still a lot of air in the loaf. If you put your finger in it and the dent remains, that means it's overproofed. If you punch your finger in and it comes back halfway, that means that it's appropriately proofed. This one came back about halfway, but that's because it was in the refrigerator, and this loaf is stiffer than it really would be if it were at room temperature. I don't typically do the poke test because if you keep good records of your proofing times and temperatures, you generally don't need to be doing that test, which is not incredibly reliable anyways. The next thing that I do is in the few minutes that I've been standing here talking, I'm looking at this loaf. It's already relaxing. I can see this loaf is kind of getting fatter before my eyes. So I'm going to move quickly here. So I'm going to score this loaf, and this is really where you can tell the first signs of overproofing is when I touch this loaf with the blade. This loaf is incredibly soft. I have a hard time pulling the blade through it because there's so much air in this loaf and it's so soft. Normally I could just drag that through in one sweeping motion if this loaf were appropriately proofed. I had to saw my way through this because it's so loose. And now look at this loaf, how all those indentations of where I just touched that with my hand, see all those indentations there? That's signs of overproofing. That just means this loaf is losing its structure. And then the real giveaway is when you look down inside that slash, this loaf is just kind of falling apart on the slash. It's opening before my eyes. And when I look down inside that slash, let me lift that for the camera. What you can see there is see all that webbing that we saw when this was coming out of the bulk fermentation bowls. I see all that webbing in there. That's a sign that this is overproofed. I can tell just by looking at it. So all the indications here, the loaf flattened out. It's continuing to open up on that scoring. It's incredibly loose. It's lost its structure. And I see the webbing, and my indentations from my fingers are still there. So when your loaf looks like this, you don't want to waste any time. Let's get this in the oven. The loaves have baked and cooled for 90 minutes. Let's take a look at what we have. Loaf number 1. So this loaf bulk fermented for 6 hours and it rose 40%, which was slightly higher than the recommended percent rise of 30% in the recipe. I've baked loaves at this percent rise before. That's really a beautiful loaf. I mean, if you look at the oven spring, the ear, and this is with no pre-shaping and no final shaping, that's really a nice looking loaf. You can tell that that really has decent gluten structure in it. It's not really pushing overproofing, at least from the outside, because it maintained the shape of the loaf, especially without pre-shaping or final shaping the loaf. This is really where you see what happens in bulk fermentation. I mean, bulk fermentation is 90% of what makes the loaf. I mean, we focus on shaping and baking and all that. It's bulk fermentation. I mean, that's just, you can't look for a better illustration than this that says if you just bulk ferment dough, throw it in a pan shaping basket and bake it the next morning, that's what you get. I mean, that's beautiful. Okay, then we move from loaf number 1 to loaf number 2. Loaf number 2 bulk fermented for 6.5 hours, so 30 minutes longer than loaf number 1, and this is really fascinating. And we went up to a 50% rise in the dough, and you can see a material difference in this loaf. It's flatter, it's shapeless, there's no arc, it didn't open on the ear. I mean, that's just kind of a sad, misshapen loaf. And the other thing I notice here is when I look down in the scoring, instead of seeing gluten strands in that scoring, I'm seeing the bubbles, round circular bubbles emerging in that scoring, which is an indication of overproofing. So this, I mean, if you just want to watch 30 seconds of the video, it's right here. This is the difference in 30 minutes of proofing between those two loaves. 30 minutes of bulk fermentation, you go from this gorgeous little loaf to kind of this misshapen mess. The only difference here was 30 minutes of bulk fermentation. Exact same recipe, everything else exactly the same. This is why people quit baking sourdough bread. Because I bake this one weekend, the next weekend I do what I think is the exact same thing and I get this loaf. I mean, this really illustrates the importance of bulk fermentation and really being able to cut it off at exactly the right point. That maximum point, I mean, we don't know until we cut these open. It's somewhere between loaf 1 and loaf number 2. I mean, you can see it right there. Loaf number 3 is interesting, especially compared to loaf number 2, because this one kind of made a comeback and we got a little bit better shape here on loaf number 3 than we had on loaf number 2. You can see that that one actually stood up a little bit more. We got a little bit better oven spring and it opened up on the ear better than loaf number 2. So it's a little surprising that this one proofed for 7.5 hours, so 1 hour longer than loaf number 2, and we went for a 60% rise in this dough, so 40%, 50%, 60%. So I would have expected this loaf to look a little bit worse. Now this is just the peculiarity of when you're baking. You'll get differences in this based on small temperature differences in the oven. For example, The oven might not have preheated as much between loaf 2 and loaf 1, and it might have been a little hotter on loaf number 3, which I can also see because this baked up a little darker. So it's possible that my oven was slightly hotter on loaf number 3. The other thing that happens between, for example, loaf number 2 and loaf number 3 is that as the loaf is inflating in the oven, it's basically filling all these small balloons, the gluten matrix, are filling with steam, and in certain loaves there creates a steam gap and all that steam just escapes. That's what happened in loaf number 2. In loaf number 3, just based on kind of the randomness of that crumb, it trapped more of the steam for a little bit longer time, so I got a little bit more oven spring on loaf number 3. That's just kind of a random occurrence that happens when you bake. It's kind of like if you're trying to blow a bubble with bubble gum, sometimes you blow and it immediately snaps, and the next time you blow and you get a perfect big bubble. That's the difference between loaf 2 and loaf number 3. It's the same gum, it's the same process, just that action of inflating the loaf can have differences like you're seeing here in loaf number 2 and 3. Loaf number 4, this is our double in size loaf. As I said, some people, say, how do you make sourdough bread? Mix up the ingredients and wait for the dough to double. This is what you get. You get a flat, overproofed loaf. I mean, I've never allowed my loaf to double and actually had it come out well. This is just classic overproofing. This is just sadness. If you tried to give this thing a name, this would be called sadness in flour and water. Look at the scoring here. I mean, you're seeing down into the loaf that honeycomb of the bubbles. I'm not seeing any gluten strands. I'm looking for some indication of vertical strands of dough. They're gone because the gluten has deteriorated inside of this loaf. That's a classic overproofed loaf. So those are the 4 loaves. I mean, also looking at them from the top down, you can see that we started with a slightly more compact loaf here on number 1, and then as you go, they kind of relax more and more as you go to the right. And then the color difference here, that loaf number 3 baked up a little bit darker, which I think just implies it was maybe a little bit hotter. When you get out here to loaf number 4, I've also seen this with overproofed loaves. They just don't darken. No matter how long you bake them, you just get kind of this blonde-ish looking, flat, misshapen loaf. That's kind of a classic overproofed look. Let's cut these open and inspect the crumb. Loaf number 1. Okay, this is a really great example of a slightly overproofed loaf. Now, if this were, I'd say, fully proofed or more perfectly proofed, you would see a little bit more of an irregular open crumb. And as you move into overproofing, you see this density of the crumb where there's no real openness to this crumb at all. If I'm looking for, kind of a large circle in here, I'm not seeing it. I'm seeing a nicely proofed loaf. I mean, it's evenly proofed throughout, top to bottom, front to back, beautiful shape. But I've lost the openness of the crumb and I'm starting to trend towards overproofing because of these small, I call it this honeycomb of these small holes, very kind of high density, small holes in the crumb. Some people will look at this and they really like this crumb, but this is what I'd call a fully proofed loaf. Maybe not overproofed, but right on the edge. This was a 40% rise in the dough, 6 hours of bulk fermentation against the recipe guidance of 30% rise. This is what you'd expect. I've made some beautiful loaves pushing it right up to this point of 40%. And if we had shaped this loaf, you can do some different things with the crumb, but just looking at the impact of bulk fermentation on the crumb, what you see here is a slightly, let me say, fully proofed to overproofed, right on the cusp between those two. That's a great example. Here's a more detailed view of the crumb and the bulk fermentation criteria if you would like to pause the video here. Loaf number 2. Okay, and this is what you would expect. Moving up that continuum between loaf number 1 and loaf number 2, what's happened here is I've lost the shape of the loaf. So I've lost that big arc, I've lost the ear. This is just a flatter loaf, and the crumb, similar to loaf number 1, looks very dense. But what I'm also seeing here in loaf number 2 is I'm starting to see the crumb separate from the crust. See right here, this crumb separating from the crust, that's a telltale sign that you're starting to overproof and that my crust is getting super thin. So that's another good example of moving up this continuum where we've gone from a 40% rise in the dough to a 50% rise in the dough, and I'm seeing this crumb progressing as I would expect. Interestingly, this was only 30 minutes difference in the bulk fermentation time. 6 hours of bulk fermentation on my left, 6.5 hours of bulk fermentation on my right. That is pretty extraordinary right there. Here's a more detailed view of the crumb and the bulk fermentation criteria if you would like to pause the video here. Loaf number 3. Now here we continue to move along that continuum. The crumb continues to get more and more dense, really clear here on the left side of this loaf. You can see the crumb getting super dense here. That's an indication of overproofing. And now I'm getting this more and more separation of the crust and the crumb, and that real thinning of the crust here. So that's a good example of what happens as you move further up that bulk fermentation overproofing continuum. Classic indications of overproofing. Not a bad loaf. I mean, this is a 60% rise in the dough. This went for 7.5 hours of bulk fermentation. This is still a pretty acceptable looking loaf, but you can see the continuum here step by step as we move up in the proofing time or bulk fermentation time. Here's a more detailed view of the crumb and the bulk fermentation criteria if you would like to pause the video here. And then loaf number 4, this is allowing the dough to double in volume. Classic overproofing right there. This is kind of a textbook overproofed loaf. See the crumb is getting even more dense. Now it's getting gummy. So it's getting gummy and dense. I'm getting the separation of crust and crumb here, and I've lost all that rise in the loaf. I've lost the shape of the loaf here, and I'm really just getting a compressed ball of dough. So this is shrinking in height. The longer I would have proofed this loaf would keep getting smaller and smaller now. So we've gone clearly past the point where the loaf is rising, and now it's shrinking. I can't do anything to this to help increase the rise of this loaf. It's just going to keep shrinking and getting more dense. Really good example there of extreme overproofing. Here's a more detailed view of the crumb and the bulk fermentation criteria if you would like to pause the video here. Here's the side-by-side comparison of the loaves. You can see clearly from my left to right. Loaf number 1, really nicely shaped loaf, fully proofed, but we've lost the open crumb and it's heading towards a more dense crumb. Loaf number 2, you have the dense crumb and you lose the shape of the loaf. Loaf number 3 actually opened up a little bit more. Maybe this baked at a little hotter temperature. But what happened here is we start to get the separation of crust and crumb. And then loaf number 4 is just the flat, dense, shapeless loaf. Now what you can see here is that you have a lot of latitude in the bulk fermentation time on these loaves. I mean, we went from 6 hours on loaf number 1 to 9 hours on loaf number 4. And loaf number 4 is still an edible loaf. I mean, this didn't turn into an inedible ball of starter that you don't know what to do with. But if you're really trying to perfect your crumb, you can see that these small changes in the percent rise in the dough or the fermentation time have material impacts on the crumb of the loaf. That's really what this video is all about. So what did we learn from this video? Number one is that determining the end of bulk fermentation is more science than art. There are objective, measurable criteria that you can look at and you can measure to determine when you need to cut off bulk fermentation. This does not need to be a guessing game. You don't need to bake sourdough bread for years and years to learn how to do this. If you really keep records and observe what you're doing during bulk fermentation, it is a measurable process. And it is easy to tell what's happening based on the outcome of your loaf. And you can work backwards and say, why did loaf number 4 come out the way that it did? Why is loaf number 2 different than loaf number 1? There's an objective reason for all those. This is much more science than art. The second thing we learned here is that when you think about the 9 criteria, the first 2 are the most important. That's temperature and time. I mean, in this example, we eliminated the impact of temperature because I maintained a very steady proofing temperature of 81 degrees Fahrenheit or 27 degrees Celsius throughout all these loaves throughout the entire process. If you're not monitoring and managing your temperature, all of this gets very difficult to keep track of because the temperature has the biggest impact on bulk fermentation. So number 1 is control your temperature. I have a whole series of videos on this called Mastering Temperature and Time. If you're having trouble managing your dough temperature, I recommend that 3-part series. It goes through incredible detail of all the techniques for managing your dough temperature. The second thing is to really measure the percent rise. And I mean really measure it. Have a vessel that it has the milliliter markers on it and very accurately measure the percent rise. These 3 loaves, 40%, 50%, 60% rise in the dough, which had a material impact on the crumb, you cannot eyeball this difference. You can't just look into a bowl of dough and say, oh, that one's 40% versus the other one's 50%. You need to actually measure this, and those small changes have a material impact. And even the doubling loaf, the 100% rise loaf, as I said early in this video, you can look at a bowl of dough and your eyes can convince you that it has doubled at almost any point in the bulk fermentation process because it's impossible to measure it, especially when you have a bowl that flares out at the top. Because the dough is expanding out as it's expanding up, it's impossible to eyeball a doubling of the dough, which means it's even more impossible, if there is such a thing, to eyeball a 10% change in the volume of the dough. So absolutely measure the percent rise in your dough and then apply all the other criteria to really confirm what the percent rise is telling you. And then lastly, the thing that we found in this example that I haven't seen as clearly in some of my other experiments is that by doing that window pane test along the way, I could feel the dough breaking down. I mean, I could feel the dough change between loaf 1 and loaf 2, between loaf 2 and loaf 3, and absolutely in loaf number 4. A lot of people do the window pane test at some point in bulk fermentation, and they say, okay, I've gotten my window pane, so I don't need to do any more gluten development, so you can stop doing stretching and folding, for example, and then they don't do another window pane after that. But what I recommend is throughout this process, feel the dough, get your hands on the dough, and try to pull that window pane because that will really indicate to you when you start to turn the corner towards overproofing. And one of the last things I recommend during bulk fermentation is really to smell your dough along the way and really make a mental note of what you're smelling, because I clearly smelled the difference between loaf 1 and loaf 2, where loaf 1 was that sweet, ripe smell that I look for when I think bulk fermentation is done. Loaf 2, I started to get that vinegary, hint of a vinegar smell right between those 2 loaves. And then clearly when I got to loaf number 4, that acidic smell even dominated all of the sweetness of the prior loaves. So there was clearly a change when I got to loaf number 4. That smell test is something that you need to develop over time, but if you do it frequently, every time you're checking the dough, every time you bake, continually smell that and look for that change from the floury smell to the sweet smell. That's when you're typically looking at the end of bulk fermentation. And then when you go from sweet to acidic, that's when you start to go into overproofing. And the last thing I'll mention for beginning sourdough bakers is don't be afraid of overproofing a loaf or 2. As I mentioned at the beginning of the video, I was afraid of overproofing and I ended up underproofing a lot of loaves. What you can see here is you have a pretty long runway here with your bulk fermentation before you get to a really sad loaf. So keep pushing your bulk fermentation a little bit more each time. Push it 30 minutes next week, 60 minutes the week after that, 90 minutes the week after that, until you find that perfect sweet spot that you're looking for. And then if you keep records of what happened when you really found that sweet spot, sometimes the best loaves are the ones that are right on the edge of overproofing. That's really where the magic happens sometime. And if you don't really push that limit, you'll never find that point. So I encourage you to always keep trying to find the edge. You'll find it eventually, and then keep records so that you know how you got there. I hope you enjoyed this video. Good luck on your sourdough journey. Now I am going to eat some bread.